So that's how you do a combined circuit. Change it into series, deal with all the calculations involving series, and then go back and deal with the parallelity that are involved in it. So let's do one more. Make sure we got this down. So again, electrons go through here and ends up over here. Voltage drop for this system. We have two different current drops here. Yeah, that's nice. Here, and here, coming out here, and here. So, the current's going to split here, but it's going to be fine going across over there. So you got this going through here, and you got out here, and then you got the current going through here, and you got over here. But it will split because it's in parallel. This is so much fun. I can't tell you how much I enjoy it. So that's what's going on with the current there, it's splitting up. The voltage drop stays the same going across. Okay? So, let's take a look at this here. We know that the R total is equal to R1 and 2 plus R3 plus R4 and 5. So that means we need to find R1 and 2. R1 and 2 is equal to, and so we go up to the first set there, it's 20 and 80 are the two values. So 20 to the negative 1 plus 80 to the negative 1, all to the negative 1 power, plus R3, we said is 40 ohms, so that's 40 ohms, plus R4 and 5. Well, we said R4 is 100 and R5 is 200. So this is 100 to the negative 1 plus 200 to the negative 1, all to the negative 1 power. So let's go ahead and punch this into our calculators. 20 negative 1, 80 negative 1, all to the negative 1 power, plus 40, plus parenthesis 100 negative 1, and plus 200 negative 1, close parenthesis negative 1 power, and we get 123 ohms. Okay, and so since we have that, we can now find the total current, because that's the total resistance. I don't know why I put all 1 and 2 there, that should be our total right there. Because my mind is going to 10 different places at once. All right, so we got I total, and that's going to be equal to, now again, we're going to treat this like it's a series of 3 different resistor systems. So the current going across each system is going to be the same. So that means I total is going to equal to I. Line is not too good shape here. I 1 and 2 well, equals I3, which equals I 4 and 5. So we take, in order to find I total, we take V total over R total. V total for this system, I believe, is 6 volts. And the R total is 123 ohms. And that's going to be 0.4088. 0.0488 amps. Okay, so, and that means then that we put 0.0488 amps for each system. Okay, so now what we're going to do is we're going to find the voltage drop across each of these three systems. And since V, I1 and 2 equals I1 and 2 times R1 and 2, I just go find the values that I've already calculated and do that. Well, I1 and 2 we know is 0.0488 amps, it's practically staring us in the face, times the resistance of the first system of resistors is, well, it's 20 to the negative 1 plus 80 to the negative 1. I didn't calculate that, so I'll have to do that right now. 20 to the negative 1 plus 80 to the negative 1. I'll put that answer just above there. I don't really have to do it. That one times negative 1 power, or to the negative 1 power. But I'll go ahead and put that value up there. 20 negative 1 plus 80 negative 1, close parentheses negative 1. And this gives us 16.0 volts. I'm sorry, amps. Ohms. Okay, so 16 ohms there. Multiply 16 times 0.0488. And I get 0.781 volts. For I1 and 2. And we know that the voltage splits evenly for the two resistors, so this is going to equal to V2 and V1. V3 you already know, so we don't have to do that. Or have we done that? Probably should. No, we haven't done that. So let's do that. V3 equals I3 times R3. So I3, we said, is 0.0488 amps times I3, which I believe is 40 ohms. It is 40 ohms. And that's going to give us 0.0488 times 40 is 1.95 volts. Okay, and then V4 and 5 is equal to I4 and 5 times R4 and 5. And that's 0.0488 amps times R4 and 5, which is, we have not calculated that either, but we know it's 100 negative 1 plus 200 negative 1 to the negative 1 power. So 100 to the negative 1 plus 200 to the negative 1, all to the negative 1 power. And I'll go ahead and do that calculation real quick. So 100 negative 1. Oops. Plus 200 negative 1 to the negative 1 power, and we get 66.7 for this. Multiply that by 0.0488, and I get 3.25 volts. for V4 and 5. So that means then that that's going to be V4 and V5, because in parallel circuits the voltage splits even between the two, being whatever the dynamic of the entire parallel system that it goes through. All right. So we now have everything except for the current. We have I3, but we don't have I1, I2. We do have I1 and 2, but we don't have I1, I2, I4, I5. And they should add up to 0.40488. So let's go ahead and do that. I2 is going to equal to V2 over R2. V2 we said is, wait, we haven't done 1. Why am I doing 2? I mean 1, 2. Well, I'll do 2 and then I'll do 1. Whatever. So V2 is 0.781 volts. R1, I believe, was 80 ohms. So 0.781 divided by 80 is 9.76 times 10 to the negative third amps. I1 equals V1 over R1 equals 0.781 volts over 20 ohms. And I believe that is going to be 0.0390 amps. And those two should add up to be about 0.488, and it does, if you do the math. 0.0488 is established there when you add those together. Now let's do I4 and I5. V4 over R4 equals, and I believe that's 0.78, I don't know. What is the V4? Oh, 3.25 volts. And I believe that's 100 ohms, if I remember correctly, for that one. Hello, and goodbye. It is 100 ohms. And then it is 3.25 times 10 to the negative 2 amps. And do one last time, doing the same thing for I5, V5 over R5, which is again 3.25 volts for the whole 4-5 system over 200 ohms. And this gives us 1.63 times 10 to the negative 2 amps. And we add those together, you get 0.0488. So amps. So ladies and gentlemen, yes, that is series and parallel together combined as one circuit. Your practice problems are attached in the Google Classroom.